On today's episode, we will be upgrading the stock firmware to Klipper firmware. And this procedure will be for all chips in our Aquila. Whether you have an STM32, G32, H32, or N32, you will be granted access to wireless printing, faster printing, more precise printing. That's what Klipper has to offer and more. And we're going to install all of it. And here we go. Folks, welcome to the channel. I am Leo of Prince Leo 3D. Thank you for joining me. If I look tired, because it's 5 a.m. right now, I had to wake up real early to try and record this because I just want to get this video to you as quickly as possible. Now, as you'll notice, this video is pretty lengthy. That's not because installing Klipper is all that hard. This is just new information for a lot of users, and I want to make sure I explain stuff as thoroughly as possible. If you already sat through this entire video, or if you know a little bit about Klipper, use the chapter markers below. I try to make them kind of accurate, so this way you can jump to a precise location in this video and start right from there. The beginning of the video, we're going to talk a little about what we're doing, why we're doing it. The middle is going to be the installation, and then the ending is going to be my final thoughts and some final prints. Now, on most Klipper installation videos, they tend to cut off right after Klipper gets installed on your printer. However, there's a little bit more to it than that. Once Klipper is installed, there's a configuration file that's unique to your printer that we need to set up. We're going to set that up today. We're going to do some initial calibrations. I'm going to show you the slicer software changes we need to make, and then we'll get a few first prints out of it. So by the end of this video, you should be able to get some first prints with Klipper on your machine. So enough of the intro. Let's get to more intro where we explain exactly what Klipper is, why do we want it, and what does it do, and how does it differ from our stock firmware. Now, I've already mentioned that Klipper is going to give us faster print speeds. It's also going to print more precisely. How does it go about doing all that? Well, to understand that, let's just talk about firmware on our 3D printer in general. Now, sitting next to me here is our 3D printer, the Voxelab Aquila. And everything we kind of see right here is what I would consider the skeleton of the 3D printer. We have our axes, our bed, our hot end, all the different rails. What moves that skeleton is the main board. That's the brains of the operation, and that's tucked right here under this electronics case. We've seen it in a few other videos. Now, I have a main board out of another printer I own right here to kind of give you an example. This is basically situated right inside here on our printer. This is one out of a printer to give you a better idea. The brain is what moves this skeleton around. How the brain operates is determined by its firmware. Now, the stock firmware that comes on our Aquila on the main board is known as Marlin firmware. This firmware is excellent. It's on, I would say, about 99% of the 3D printers that are being sold right now because of its reliability and its ease. Now, on this channel, you may have heard me refer to Alex's firmware and upgrading to that firmware. That firmware is still Marlin. The overarching framework of all those firmwares is Marlin. And the way Marlin operates is it has the main board of our 3D printer perform all printing related tasks. That means it's going to read, interpret, and execute all the G-code commands while we are 3D printing. I plug an SD card into this, I hit print, and all the commands necessary to complete that print are handled by our main board, by the microcontroller. Makes sense. Now, how Klipper operates is the same way. It's going to read all the G-code, perform all our commands, but it separates the commands between this microcontroller, our main board, and an additional microcontroller. Normally, that microcontroller is a Raspberry Pi. And I have one here. This is a Raspberry Pi Zero W. Klipper looks to offload some of the tasks our main board would do onto a microcontroller that is more proficient at it. Our Raspberry Pi, the microcontroller, is going to help the main board perform all the tasks of 3D printing. And it's important to note, with Klipper, a Raspberry Pi isn't the only option we have. Anything that can run Linux operating system can run Klipper. So if you have an old laptop, an old PC laying somewhere, if you can install Linux onto it, it can run Klipper, and then it can help your main board print. This additional microcontroller, the Raspberry Pi, is better at processing certain commands. For instance, all the computational commands that our G-code files, our sliced model files, are made up of. This is a better processor. The Raspberry Pi computes everything, and it sends executable commands to our microcontroller. The main board of our 3D printer only needs to execute commands that the Pi gives it. It no longer has to do any computational work. This allows us faster speeds and more precise movements because the main board is only controlling movement and this additional microcontroller is doing all the computational work. Now, if you've watched any videos on this channel, you know I like really base, vanilla examples, and here's one of them. It's a little wacky. Let's say, for instance, I had a chalkboard right here, and next to me, I had a stack of 10 pieces of paper, and we're going to play a game. Every piece of paper has a single math problem on it. I'm going to look at the papers one by one, I'm going to solve the equation, and I'm going to write the answer on the chalkboard. And this will be a timed game. So I'll take the first sheet of paper, the timer starts, I look at the math problem, I figure it out, I write the answer on the board. I go to the second piece of paper, same thing, I write the answer on the board. Third, fourth, fifth, until I'm finished with all 10 pieces of paper. All the answers are on the board, and the timer stops. Let's say I did that in about 1 minute and 20 seconds. That's an example of how Marlin works. There's one person, one microcontroller doing all the work. I'm figuring out the computational problems, and then I'm executing them by answering them on this chalkboard. Now, let's introduce another person. My cousin, Jackie, or Dr. Jackie in this example, because he has his PhD in physics, and he is infinitely smarter than I am. Now, Dr. Jackie is going to handle all our computational work. In this version of the game, Jackie is going to go through those 10 pieces of paper. He's going to solve the problem, he's going to write it on the paper, and he's just going to hand me it. All I need to do is take the answer from the paper and write it on the chalkboard. So we start the game again. Jackie hands me the first piece of paper, the answer's on there, I write it on the board. The second one with the answer filled out, I write it on the board, and by the time I'm done, the third one with the answer filled out is in my hands. We go through all 10 pieces of paper, the answers are on the board, and we did it in 20 seconds. That is how Klipper operates. I have a microcontroller or another person doing all the heavy lifting for me, all the computation. All I have to do as the microcontroller is execute those commands. All I did was write them on a chalkboard. All our 3D printer is going to do is execute stepper motor movements. That's it. This allows us to print faster and print more precisely because we've offloaded the processing to something smarter than us, and all we need to do is execute. Now, adding this extra microcontroller and installing Klipper doesn't only just increase our speed, it also gives us access to other great features like pressure advance. And what that does is account for the pressure within the extruder. Another benefit of Klipper is input shaping or resonance compensation. And what that does is looks to reduce effects of ghosting or vibration in your 3D printer. Naturally, there's going to be some vibration imparted to your 3D printer. And now that we're able to increase the speed of our print head, those vibrations are only going to get exacerbated. Input shaping looks to counter or reduce those vibrations and prevent any ghosting that may occur on the outside walls of our model. We also don't need to flash our firmware or our mainboard each time we make a change to our 3D printer. For instance, with Marlin, when I had my regular stock Aquila and I upgraded to a BL Touch Aquila, I had to go on my computer, compile a brand new set of firmware, and then flash that onto my printer. We don't need to do that anymore with Klipper. Once we flash Klipper onto our 3D printer, every change we make is going to be a simple text file. All we'll have to do is add some text to our configuration file, hit save, and that's it. Our printer is now updated. Also, did I mention we're going to be able to wirelessly access our 3D printer? I know I did at some point. That means I can be in any room of my house and have complete control of my 3D printer. If you're using a Raspberry Pi 3 or 4, you're going to have the ability to add a camera to that so you can watch your prints from any room in your house. Now, it seems like a luxury, but for some people, it's a necessity. Mobility issues are a concern. Or if you have your 3D printer in a hard-to-get-to location, if it's in a basement, if it's outside in the garage, it's not necessarily easy to access those. As we're all getting older, I know I don't want to be going up and down the stairs all the time. Anything that can open up a web page is going to be able to access your 3D printer. A phone, a PC, a laptop, a tablet, a Fire tablet, anything like that. If you can open a web browser, you'll be able to access your 3D printer. There's got to be some negatives, right? Well, there certainly is. And the biggest one you've already heard me talk about, additional hardware. We need another microcontroller to work with Klipper. Now, in our case today, it's going to be a Raspberry Pi Zero. Nowadays, though, I'm sure you know, finding a Raspberry Pi is really hard. Finding one that's affordable is even harder. They are charging out the nose for Raspberry Pis now. So this is a big enough hurdle. Now, like I said, anything that can run the operating system Linux can run Klipper. That's still a hurdle for certain people, and I know it's a non-starter for others. Now, along with the additional hardware of a Pi, we also need to power this Pi, so that's even more hardware. And then we need to connect this Pi to our printer, additional hardware. So that's a data cable, a power cable, and a Pi itself. And now also, we're going to lose the ability to use our screen. After we flash Klipper onto our 3D printer, it is no longer going to be compatible with our screen. For me personally, I don't find it as really a hindrance because we're literally going to have access to our printer from almost any device we have on us. Our phone's usually in our pocket, you might have a computer somewhere, you'll be able to access it everywhere. And the last negative of Klipper is the time sink. You have to watch this video, you have to actually install Klipper, you have to learn sort of the new peccadillos of Klipper. If you have a single printer and you're having a great time, Marlin's working good, maybe Klipper isn't a necessity for you. And by no means is Klipper really a necessity for anyone. Klipper is just going to give us some upgraded feature, and I personally believe some better prints. Everyone's got a life outside of this hobby, right? So if you don't have the time to devote to installing and maintaining some new firmware, then maybe Klipper isn't for you. But if you have a Pi, if you have the time, you want to delve into this new and unique firmware, stick around because it is fun, very fun. So now let's look at what we're going to need to perform the installation that I show on this video.
For today's installation, we'll be using a Raspberry Pi, and that could be any Raspberry Pi you have available except for the Raspberry Pi Pico. Then you'll also need two SD cards. One SD card is going to act as the operating system for your Raspberry Pi. That should be a minimum of 8 gigabytes, and it's preferred that it's high speed. The secondary SD card is simply used to flash Klipper onto the Aquila, and that could be the SD card that came with your printer. Then you'll need a data cable to connect the Pi to the Aquila, and keep in mind the input USB for the Voxelab Aquila is a micro USB. Finally, we just need a power supply to power on and maintain our Raspberry Pi.
And for today's installation, we're going to be using a script to help us, and it's called kiauh, K-I-A-U-H, Klipper installation and user helper. It really boils this process down to just copy and pasting lines of code. So everyone involved for creating and maintaining the kiauh GitHub, we thank you. So without further ado, let's get to installing Klipper on our Voxelab Aquila. The first step is to take that high-speed performance SD card that you kind of splurged on and plug it into our computer, and we're going to flash an operating system onto this.
The first thing we want to do with our SD card is format it. Now, whenever we format an SD card, it will erase all the files, all the media off that SD card. So if there's anything on there you want to keep, make sure you moved it off beforehand. I've opened up my File Explorer. I found my mounted SD card right here, and as you can see, I've moved all my files off already. I find it in the File Explorer, I right-click it, and a menu comes up. I'm looking for the option to format. I click on Format, and yet another menu will appear. And now this is where we're going to choose how to format it. We want to choose FAT32 file system and 4096 bytes for the allocation. This is how it has to look, FAT32, 4096 bytes. After that, you can choose the quick format if you wish, hit start, and the formatting will begin, but not before warning us one more time that everything will be erased off this SD card. So this is your last opportunity to move anything off that you don't want to be lost. I hit OK because my SD card has been already removed of its contents, and the formatting begins. It's pretty quick. I get a notification when it's complete, and we can move on. Now that our SD card is formatted, we're going to flash the operating system we want to work with on there. This is going to be the first of the 3 free softwares we use. This is Raspberry Pi Imager. You can go to the website and download it. When it opens up, it'll look similar just to mine right here. So the first thing we're going to do is choose an operating system. We click this button, and a bunch of different operating system choices come up. What we're looking for is Raspberry Pi OS 32-bit Lite, the Lite version. So that's under the Other section, and then it's the first one right here. Raspberry Pi OS Lite 32-bit. Click on that. That's the operating system we want to use. Next to that is storage. That's the SD card. We need to find that. I click on choose storage, and the only thing I have mounted right now is my SD card, so it's a very obvious choice for me. But if you have other SD cards mounted, make sure you are selecting the correct one. You do not want to try and write an operating system onto something that is not prepared for it. Now the next step would be to write. That would just simply write the operating system onto our SD card. But we want to make some changes beforehand. These changes are going to make our life a lot easier once it comes to setting up our Pi. We click this little gear icon, and an advanced option menu opens. The first thing we want to do is we want to change the host name. I have multiple Raspberry Pis in my home, so if I try and search for Raspberry Pi.local, I don't know which one I'm going to ping. So for this example, I'm just going to write Klipper setup. You can name this whatever you want. This is going to help us identify our Pi later on. So you can name it whatever you want, .local, but make sure you remember the name. After that, we're going to enable SSH. SSH is the function in which we're going to be able to wirelessly communicate with our Raspberry Pi. This is what's going to be called a headless setup. Our Pi is not going to have a keyboard, and it's not going to have a monitor. So we're going to use the computer we're currently on right now to access that Pi and to make changes to any files. Enabling SSH is how we do that. Down here, set username and password. Username, you can put whatever you want. I usually keep it as Pi. And then you can write yourself an easy password, a hard password. Whatever you write, make sure that you jot it down somewhere else so you do not forget it. That's how we're going to log into the Pi. After that, we're going to configure wireless LAN. This is basically going to tell the Pi what wireless communication, what Wi-Fi it's going to be using. So right now, I'm tethered to my phone, so it already pre-populates my SSID. So if your computer is logged on to the same Wi-Fi your Raspberry Pi is going to be using, all that information will be pre-populated. If not, this is the time to add that. You're going to put the Wi-Fi name, and then you can place the Wi-Fi password. So when the Raspberry Pi powers on, it can immediately connect to the Wi-Fi. After that, you're going to select your country. I don't know that this is a necessary step, but I will say I always do it. I am in the US, so I have to scroll all the way down to US. I have to imagine this has to do with time zones and timing issues. I don't think that's a real big problem for us, but it's better to be safe than sorry. And that's it. After all those different fields have been filled out, we can hit save. And now we can go to write. We have the right operating system. We have the right SD card that we're writing that operating system onto. We've made adjustments in the advanced options, so our life is a lot easier. And now we're just going to click write. It lets us know yet again, anything on that SD card is going to be erased. We already did that. We don't worry. So we want to continue. Now this may take a little bit, maybe 5 to 10 minutes, so you can relax. When it is finished, it may ask you to format the disk again. Do not do that. If you reformat it, if you remember, it will erase everything on the disk. Some Windows PCs ask you to do that, some don't. So if it does ask you, cancel it, deny it, do not reformat it. And right here it says write successful, and it shows that my operating system was written properly onto the SD card. It's already dismounted it for me, so all I need to do is remove it from the computer, and we can move on to the next step.
We've removed our SD card from our computer. Our operating system has been flashed onto this card. We're going to put it into our Raspberry Pi, and then all we need to do is power on our Raspberry Pi. I plug my power supply into the wall, and then I plug it into my Raspberry Pi. Give it 2 or 3 minutes to perform all its necessary startup routines. It's going to immediately connect to the internet, and then after those 2-3 minutes have elapsed, jump back onto the computer, and we can continue with the installation.
We will now be using the second of our free softwares, and this is called Putty. When you download and open it up, you'll have the same screen as I have right here. This is going to be able to give us access to the Raspberry Pi wirelessly. Now, the way we're going to do that is through the IP address. However, if this is our first time turning on the Pi, we don't really have the IP address. Now, if you have access to your Wi-Fi's administrative settings or its administrative page, it's very possible you can go on there, you can see all the devices connect to it, and you can start using the IPs. But if you live in an apartment, a dorm, some other spot, you're using public Wi-Fi, I don't know. If you cannot get that IP address, we're going to use that .local address that we set up during the writing of the software, of the operating system rather. So I used Klipper setup .local, whatever the host name .local was in there, and then I click open, and it's going to try and communicate with my Raspberry Pi. Now mine was very quick. It usually takes a few more seconds than that. A potential security breach warning comes up. We hit yes, we know it's our Pi, and now we can log in. The first thing that comes up is the login name. So our name was Pi, at least that's what I kept it as. Hit enter, and then a password screen. And now you're going to enter the password that you put in for your Raspberry Pi during the setup phase. And just like that, we are now in our Raspberry Pi. We are at the command line, and we can make any settings or changes that we need to make. Before we move forward, there's one thing we need to find out that will help us, and that's the IP address of the Pi. We've been logging in with the hostname.local for now, but we need to get the IP address. It's a simple command, ifconfig, hit enter, and it will give you a load of information. We'll be looking for the WLAN line, and then right here it will give you the IP address. So that's 192.168.242.41. That's for my specific Pi. Do not copy that. It will be different for every unit. Now we can use this IP address to log into our Pi from now on. The first command we're going to send our Pi is just to make sure it's up to date. And now all of this is basically going to be copy and paste from here on out. Everything is going to be in the description, all the steps. And then if you go to my website, I'm going to have a text-based tutorial on all these steps. So if I'm speaking too quickly, if I'm going through things too fast, those are two avenues that you can read through and take them at your own pace. The first command is sudo apt-get update. I copy it in there and I hit enter, and then it runs that command. And this is going to update our Pi to make sure that all our libraries and all our repositories are up to date. Once that is finished, our next command is to install Git. Now, the rest of these commands can be found directly from the kiauh website. I'm going to link that also in the description, or you can just use the commands as I am going through them. Git is necessary to install kiauh, which is going to help us, tremendously help us, install Klipper, install Moonraker, and then install our front end. Kiauh makes this process so simple for us that it's really mind-blowing how easy it is. If you're worried about this at this point, do not worry. We are going to get through it. Now this last command is going to be a block of commands, and then after that we are in kiauh. So it's changing the directory, and then it's cloning the GitHub that kiauh is kept at. So it's going to immediately open up the kiauh main menu once it is complete. It's completed, and now we are looking at kiauh's main menu. Now, if you have an N32 chip in your Aquila, these are the next steps you need to take. If you don't, if you have a G32, skip to the next chapter. You don't need to do what we're about to do. We need to change the repository to access information for the N32 chip. We are going to quit out of kiauh by using the Q command, then hit enter. We're back to the Pi, and we can actually close putty out. So I'm going to X out of this, closing the session. And now we're back to just our computer. We're going to now use WinSCP. This is the third piece of free software. Everyone else is going to use this later on in the video, but right now, we are going to be using this right now. I have it here, but I'm going to search for it, open it up, and your WinSCP is going to look just like mine, and it's similar to putty. It's another way to SSH or to wirelessly communicate with our Pi. And the same scenario applies. We can put in the host name or the IP address, and then we can already pre-populate the username and the password, then log in. Same sort of warning comes up. We know what it is. It's our Pi. We can hit yes, and we can access it. Now, the way WinSCP works, it's a little different. It doesn't just look like a terminal line like putty. The left side of the screen here is all the files and folders local to your computer that you're using. So for me, this is my laptop. And on the right, this is the Pi and all its folders. So what we want to do, we see right here, the first folder we have is a kiauh folder. We're going to open that up. And we're looking for Klipper repos.txt example. Open that up by double-clicking it. And all it is a simple text file. Now, this text file actually tells you exactly what you need to do. This is extra repos that our Raspberry Pi is going to pull information from. The base repos. Now, when I say that, all I'm meaning is really just a library. The base libraries that are used for Klipper don't have the information. For our N32, we need to tell them where to look for that information, and we do that in this text file. So what we do is we're going to delete all these example files or example links down here. So now that we've deleted the bottom example repositories, we need to add our custom repo, and the place we get that is GitHub. That is where it's being hosted by Stas2Z. What we need to do is direct Klipper to go here and get the correct libraries or repositories. So to do that, and again, this is all going to be in the description. You don't need to do what I'm doing. You could simply copy and paste. I'm just kind of showing you where all this comes about. I lower this code button, and I get the current link. I can copy that, and that link for the GitHub is going to get pasted right here at the bottom of this text file. Then I need to point it to the correct branch. So right here, I can check how many branches there are. There's 3. The active branch is Aquila N32. I copy that. Then I paste that right at the end. So now when we go to look for the repository in Klipper, this is where it's going to point. We need to point it to this location because this has the information for our N32 chipped Aquila. Now I'm going to save this text file. Once it's saved, I can close it out. Now I need to rename this because I need the .example to go away. I right click it, I select rename, and then I'm going to erase or delete everything after txt. So .example goes bye-bye. I save it, and now immediately you can see it turns into a text folder because now it's only .txt. That's what we want to do. That's how it needs to look. After that, we can close out WinSCP, and we can rejoin the tutorial proper. In order to do that, we open up PuTTY, we log back into our Pi, username and password as always. Then we're going to change to the directory to Kiauh. And then after that, we're going to reopen the Kiauh menu. We're now back all on the same page, and we can continue with this tutorial. And now first thing I'm going to do is maximize my screen so you can see everything a little better. The first thing we need to do is install Klipper itself, Moonraker, which speaks between our front end and Klipper, and then our front end, either mainsail, fluid, or if you wish, Octoprint, but I will not be going over that in this tutorial. So we're going to select number 1 right up here, and then hit enter. We start with the firmware and the API. Klipper is number 1, so I select that one, and then I hit enter. Right now I'm using Python 2.7. I believe it's obsolete as of the beginning of this year. Python 3.x is saying experimental still. I use Python 2.7 on all my builds. I haven't had a problem yet. I'm going to choose Python 2.7. That's 1. I hit enter. And it wants to know how many instances of Klipper we're going to set up. For this installation, it's going to be a single one. I hit enter to that. Then I hit yes, Y for yes. And it starts doing its thing. This can take a while. Sit back, enjoy yourself. You don't have to do anything during the installation, and we'll pick it back up once it's all finished. So 17 minutes later, and my installation of Klipper is almost complete. It's now asking if I want to add the Pi username, which is what we're logged into on this Raspberry Pi, to the group, and we do want to do that. So we hit yes and enter, and it adds it, and we are finished. So that clocked in at a total of about 18 minutes for me to install Klipper. Once that's finished, though, we can move down the list, and now we're going to look and install Moonraker. So that's number 2. I enter 2. I hit enter. And it's the same thing as the Klipper installation. We're going to answer a few prompts, and then it's going to do its thing. Do we want to install Moonraker? Yes, we do. And now Moonraker is going to be the API or the interface between the Klipper firmware and our front-end web interface of either mainsail or fluid. So Moonraker is what communicates between these two. We're never really going to know it's there, and that's its purpose. It's just supposed to make a very streamlined experience for us. So sit back, again, relax. This shouldn't take as long as the 18-minute Klipper install, at least for me, but this should take a little bit of time. Moonraker installed for me in about 8 minutes, much quicker than Klipper. And now we're on to the final portion of the installation, and that is our web interface, which is right down here. You have the option of choosing either mainsail or fluid. I always choose fluid. I have way more experience with it. I think it's a really, really good interface. It's clean. It does everything I need it to do. So that's what we'll be installing today in the tutorial. So I am going to select number 4, then I hit enter, and it looks identical to the last few installations. At some point during the installation, you are going to get prompted if you want to add webcam support. That would be downloading the MJGP streamer. If you have a Raspberry Pi 3 or 4, by all means, those can handle a webcam just perfectly. If you're running a Raspberry Pi 0W though, like I often do, those really aren't powerful enough to handle webcam support properly. You're also going to be prompted if you want to install recommended macros. Yes is the answer to that, even though we're probably going to get an upgraded config file. Having some recommended macros in there at first will give us a good idea what we're looking at. So just hit yes to that and keep moving. Fluid finished up installing for me. It took around 15 minutes. I don't remember it being that long, but I guess it is what it is. So expect a little bit of a wait if you are going to be installing that. That is it. We have installed the 3 horsemen of the Klipper apocalypse onto our Pi, and we're ready to move on. Klipper was installed, Moonraker, and then your web interface, we did Fluid. Now all we need to do is create the firmware that's specific to our printer main board, copy that onto an SD card, and flash the firmware onto our main board. That's it. We're almost there. Now we're going to go back a menu, so we hit B and then enter. Now it's at this point that we're going to do some divergence between the chips. If you are an N32 chip Aquila owner, please follow this next port. If not, you can skip this chapter. This is N32 only. Hit 6 and go into our settings. We need to select that custom repo that we added to the text file earlier in this tutorial. From there, we're going to look to set a custom Klipper repository. Number 2, hit enter. After that, our custom repo that we installed is going to be the only one up there. So we're going to hit the number 0, hit enter. It's going to warn us that the current Klipper repos will be erased and replaced with this custom repository. That's exactly what we want. So we can hit Y and then hit enter, and the Klipper repositories will begin to switch. This should only take a few minutes, but once it's successful, it'll tell you that our new branch has been switched to the kiauh.sh version, and that's exactly what we want. We can now hit B for back, then enter, and then one more screen back, B, enter, and now we are all yet again on the same page. Going forward, if you're an H32 user, you do not need to follow along with this next portion. My N32, my STM32, my G32 chipped Aquila owners, please continue. The next thing we're going to do is go into the advanced menu, number 4, and hit enter. And from here, we're going to select to build only firmware. So for me, that is the second option. So I put 2 for build only firmware, and then I hit enter. When this menu opens up, we are now going to create the firmware image for our respective chips. Now, I don't know if the term firmware image is actually correct. I've heard it thrown around a few times, and I really like it. So that's what I'm using, firmware image. Okay, navigating this menu up and down on your, I would call it a D-pad because I'm from the 8-bit era, but I guess this is a up and down arrow on the keypad of your computer, and the right arrow selects. Now, the first thing we want to do is enable extra low-level configurations. Everyone is going to be doing this. That opens up more options. We drop down microcontroller architecture. We need to change that. Hit right and bring it down to STM microelectronics, STM32. Everyone will be selecting that as well, and we select that by hitting right on the control pad. Below that processor model, that's going to stay the same for everyone. We skip this, only 10 KIB. We don't need to worry about this. Now, if you have a G32 chip in your Aquila, you will select this, disable SWD at startup for GigaDevice STM32. That's the G32s. If you have an N32 chip in your Aquila, you will select this option, build for nation N32 G45X MCU. If you have an STM32 chip, you will select neither. You will just keep moving on. All the chips, we're all going to do the same thing here. Communication interface, I enter this menu. I go down one space to serial on USART1, PA10, PA9. We select that. Baud rate should be 250K. That's perfect. And that's it. We're good to go. It was very simple, was it not? Just to recap, G32 images should look like this. N32 images should look like this. STM32 images should look like this. Nothing extra need be selected. And that's it. When we're finished, after you've selected the appropriate model, I'll do N32 for this scenario. Once you're finished, we're going to type in Q, which will quit, and it will prompt us to save. We do want to save the configuration, so we type in Y, and now it builds the firmware for us. After a few minutes, you'll get a notification that your firmware has been built, and now we can close down PuTTY. Hit B, enter. We can quit out of here, Q, enter. Now we can close down PuTTY. Now our next step is to copy that firmware file we just built onto an SD card. I have mounted my SD card. I find it with my File Explorer right here. And again, we did this once earlier. We're going to format this. Right-click, Format. The format is the same as before, FAT32, 4096 bytes in allocation size. Of course, again, if we format it, it's going to erase everything. Make sure there's anything on this SD card you want to save. It's off already. And then once I have everything cleared of the SD card, I start the format. And now we're going to use the third of the free softwares that I spoke about earlier, and this is called WinSCP. It's very similar to PuTTY. My N32 owners have already heard this speech from me. This is another way to wirelessly communicate with our Pi. So we do the same thing as PuTTY. We enter the IP address that we want to access, which is a Pi, and then from here we can already pre-fill the username and password. Now WinSCP has a better interface for us. The left side here is all files and folders local to our computer, and the right side are files and folders local to whatever we logged into, and in this case it's the Pi. What we're looking for is the Klipper folder, which is right here. Double click to open it, and then we're looking for the out folder, which is right here. Double click that to open it, and then we're looking for clipper.bin. That is our firmware. So now on the left side of WinSCP, I want to locate and select my SD card. I drop down this menu here, and right here, this is where I have it mounted as a D drive, so I select it. There is nothing currently on it, which is good. All I need to do to copy this file over is simply drag and drop it. That's it. It's copied. Now we can close down WinSCP by using the X right up here. We don't want to save this, and that's it. Now I can double check, open up my File Explorer, navigate down to my D drive, the SD card, and there it is. Now, of course, we need to do some more work in order to get this properly executable as firmware for our Aquila. This next part is only for my Aquila owners that have an H32 with their printer. We've mounted an SD card. We need to format it first, and this was just like before. I find the XD card with my File Explorer. I right-click it. I select Format, and the same formatting goes. FAT32, 4096 allocation bytes. Make sure there's nothing that you need to keep on this SD card because it will be lost once we format. Once the formatting is complete, we're going to download our .bin file. This website is in the description, but this is Steve Gotthard's H32 Klipper repository. They've done all this work for us, and we get to reap these benefits. We navigate to this website, drop down to the assets, drop this down, and we're looking to download the Klipper_01.bin. Click it, and it will begin to download. I open up my File Explorer. I go to my Downloads folder. I copy the Klipper.bin. Then I navigate to my SD card, and I paste the file right in here. That's our firmware file. It's really simple for us. The steps we need to take now for this to flash on our Aquila are as follows. We need to create a new folder, and it needs to be named Firmware. Simply Firmware. Everything's lowercase, nothing's capitalized. And now we can place this firmware file into that folder. All you need to do is make sure this file is not named anything that's been flashed previously. I doubt you flashed anything named Klipper. But what I like to do is after this, I like to write the date just so I know when I did it, and it usually makes the file name somewhat unique. I can eject this SD card, and I should be able to flash this firmware. Now we take our SD card, plug it into our power down printer, and then turn the power on. You'll see the screen begins to glitch out. Then after about 20 or 30 seconds, the Klipper firmware should have taken. We can now power the printer down and remove the SD card. Now we can access our printer from the internet. To do so, I open an internet browser and input the IP address we've been using into the address bar. Now we are looking at the homepage of Fluid, which is the front end we are using to manage our 3D printer. You can see there's an error, and that's because we have not yet configured our printer within Fluid. So let's do that now. On the sidebar to the left of the screen, click on the Configurations tab. Now find and open the printer.cfg file. This is our printer configuration file, and it tells the firmware everything it needs to know about our physical printer. That would be the max temp, build size, pin mappings of our board, BL Touch or non, bed mesh information if you have a BL Touch, so on and so forth. This document is the end-all be-all for our printer within Klipper. As you can see, there is none of that here right now, so we need to add it. Now for a completely custom printer, this could take some time, but for more common printers like our Voxelab Aquila, there are already vanilla configuration files for us to copy and paste, and then we can customize them to our specific machine. So let's find that now. We'll close this out, and we'll move to the right side of the screen. I click on config_examples, and this will open up all the configuration examples or the vanilla configurations that Klipper has. In the search bar, I'll write Aquila and search and see if there's one listed. As you can tell, there are no results. Now, if you have an N32 Aquila, you actually are going to get a result. For everyone else, we'll have to do some extra work to get there. We're going to open up a new internet tab, and we're going to navigate to the GitHub that is hosting the N32 firmware for Klipper. Now, this is provided to us by Stas2Z. We thank them very, very much. They made the N32 Klipper possible, as well as giving us an example configuration. To find it, I go down to the branches drop-down. I make sure I have Aquila N32 selected. Then I go to the configuration folder. I click that to open it. Now we are in the configuration folder where all the vanilla configurations are. I'm going to use Control F to find it a little quicker. I type in N32, and then it finds it for me. Now click on it to open it up. There's a lot more information here. Now we want to copy this and paste this into our printer.cfg. I use the top right button here to copy all the text, and then we go back to our printer, open up our printer.cfg file. Now we're going to delete these two sections. We want to keep fluid.cfg, everything else can go, and then we just paste in the printer.cfg that we copied. Now this configuration file is chip agnostic, even though it is in the N32 repository. This will work with every chip, STM32, G32, H32, and of course N32. Now, whenever we make an adjustment to our .cfg file, we want to save it and then restart Klipper. Restarting it is what lets that new configuration file take effect. The button right up here, save and restart. That's exactly what we want to do. I click that, it saves the file, and it restarts Klipper. And now when Klipper starts, it's going to use that new updated configuration file. And you'll see I have no issues. I am ready to go. And as you see, Klipper is not reporting any issues. If I was to hit the home tab, you'll see I have thermals, I have a reading on my nozzle and my bed, and everything is working properly. Now you might run into an issue just like this. That has to do with something we have to input within printer.cfg. Let's do that now. Reopen printer.cfg and go down to the serial section. Your serial address is likely wrong, and the Raspberry Pi and the printer are not speaking properly. So what we're going to do is minimize our internet tab and reopen PuTTY. Log back into our Raspberry Pi, and we want to do this while everything is hooked up and everything is powered. Once we're back in the Raspberry Pi, we're going to run this single text command. After we input it and hit enter, it gives us back an address. We copy that, we go back into our printer.cfg file, and we paste it next to the serial section. That gives the Raspberry Pi the right address for the printer, and they can speak properly. We can now save and restart our firmware, and that MCU error should have gone away. That's likely not going to happen to everybody or anybody even, but if it does happen in the future, even on a different printer, this is the solution. We have everything hooked up properly. I'm getting no errors through Fluid, but now before I move on, I just need to make some changes to the printer.cfg file for my specific printer. This is a vanilla configuration. I have some add-ons that I need to adjust within my printer.cfg. The only one I have to do for my printer is a BL Touch within this configuration. The only stipulation is it can't be within another block of text. I just need to find some open space and paste some stuff in here. I have a BL Touch, so I need to add language for that. I'm going to add 3 sections. I paste it in right here. Those sections are BL Touch, Safe Z Home, and Bed Mesh. Now all this information is from other configurations I already have with other printers. All my configuration files are going to be available on my website. So if you have any questions or if you want to copy my configuration, you can go there and do so. Now I'm going to gloss over this information because it's kind of outside of the range of what we're doing here today. But the BL Touch section is going to talk about the actual physical BL Touch. That's where we're going to put my X and my Y offsets. Safe Z Home is where the BL Touch is going to home, and I want it to home somewhere around the middle of my bed. The Bed Mesh is now going to be our new probing grid. The probing operation where we create a bed mesh is all controlled under this information. Now that itself is very important, and again, outside of the range, outside of the scope of what we're doing today, I'm going to follow up with a very short video on how to calibrate all that because it is very important if you have a BL Touch. I've added that stuff. That's the only things I need to add right now for my printer in order to auto home it and get it started. I save and restart because I want to save this information and I want it to take effect. And then once I do, I navigate to the home menu and I can home all my axes and make sure that the auto home function is working. Before we do our initial calibrations and first print, I want to give you a tour around the Fluid menu. This is the home screen of Fluid, and this top left box here is the status of our printer. When I'm not printing, the ready option shows me the previous print and gives me some information on it. Reprint has the last 3 models I printed for easy access to reprint it. Next to that is the thermals. This is our nozzle. Current temperatures of our extruder, our nozzle, and our heated bed. That's the bed, current temperature. If I want to change the temperature, it's as simple as writing in the target temperature, hitting enter to execute. The power of the heating cartridge goes to 100 and my temperature starts to increase. Same goes with the bed. All I need to do is enter a temperature in the box, hit enter, and it will begin to go there. I'm going to cool down by going 0, 0. Below the status box, tool. This is the print head. This is where we move our print head. This is the x-axis, left and right, y-axis, back to forward, and here is the z-axis control, up and down. These are the increments that we will move all those axes: 1/10 of a millimeter, 10 millimeters, 25, 50, and 100. Klipper has a safety feature where it will not let you move any of the axes before you home all. So you have to do that before you want to move any one of these individual axes. If you want to turn the stepper motors off to move the print head around, for example, this little drop down, motors off. Also, if you want to snap to a specific location, you can input it in the boxes right here, and the print head will snap there. If you need to recalibrate your E-steps, this is the extruding menu. This is where you're going to do it. The length of the extrusion, right now it's set to 10 millimeters, and the speed. Currently, I don't have the option to extrude or retract. The nozzle has a safety temperature. It's usually 170 degrees, so you'll need to bring your nozzle to that temperature in order to extrude the amount of filament. All those parameters should be written within your printer.cfg. To the right of that menu, under thermals, is console. This is basically the terminal line of our printer. This is where we issue commands, and then the printer tells us what it's doing. I'm going to hit the little trash can, and I'll show you a very simple command. Homing all the axes. That's a G28. So it shows me in the console exactly what it's doing. We're going to be using this very shortly. This is one of the most helpful things that Klipper and Fluid have in store for us. If you need to know some of the initial commands, enter help, and these are some helpful commands that you can run. Now, if anything is written in your console, for instance, save config, if I click on it, it will get populated into the bottom of the command line, and then I can execute that. Under that, jobs. This is basically the SD card of our printer when we had Marlin. These are all the available print jobs or G-code files that I have saved onto the Pi that we can use to print. If I want to add a file, I hit the plus icon, I can upload it, or I can upload it directly to print. If I want to print one of these files, all I need to do is click on it, and the option comes up. I click on it, I can print it, I could rename it, I could remove it, I could preheat to the given temperatures that are within that file. There's more menus. If you have a camera, you'll have a menu down here for it. There's other menus there. We're not going to go over these today. These are the 4 menus we're really concerned about. If I want to change how these menus are oriented, top 3 dots, then adjust dashboard layout. And right here, you can see I have 4 available columns. I can move these over and make it 4. I left click the dots of a menu, hold it, and then I can move it over. When I exit the layout mode, however I left it, that's how it will appear. So adjust these accordingly and get them comfortable for you. Now for some initial calibrations before we start our first print. The first 2 calibrations we're going to do are PID temperature calibrations. We're going to tune our hot end and we're going to tune our bed. Within Fluid, we go to the console and we input a single command. This right here is the command to tune the hot end. The only thing we need to edit is the last set of numbers. You want to set this number to wherever your current printing temperature is going to be. I'm going to be printing PLA at around 205, so that's what I set it to. I hit enter and a PID auto calibrate begins. This is going to take several minutes, but at the end, it's going to give me the option to save my configuration. I'm not going to do that quite yet. I'm then going to calibrate my bed PID, and that is this command here. Again, I need to edit the last number to what my bed is going to print around. I'm going to be printing at 60 degrees Celsius, so that's what I set my calibration number to. I hit enter, and now the bed calibration begins. When the bed calibration is done, and it will take several minutes, we get the option again to save config. Now we want to do that. We click on Save Config in the console. It populates it in the terminal line for us, and we send that command to the printer. What that does is the same thing the Save and Restart command did when we were in our printer.cfg. It saves those calibrations we just had to our printer.cfg, and then it restarts for us. Now we're going to check to make sure those calibrations took. Let's open up our printer.cfg, and we're going to scroll down to Extruder. And you'll see we have this additional information here. And then if we scroll all the way down to the bottom of our .cfg file, you'll see we now have settings for our PID extruder and our bed. Now, while we're in our printer.cfg, we're going to calibrate our E-steps. Now, if you already calibrated your E-steps, this is going to be really simple. If not, you're going to need to go ahead and recalibrate your E-steps. Now, Klipper calls E-steps rotation distance. The general principle is the same, but the formula is slightly different. Doing an entire rotation distance calibration from scratch is outside the realm of this video. I'm going to have a future video on that. But if you already have your E-steps, which I really hope you did, converting it to rotation distance is so quick. The formula for this is the amount of rotations in our stepper motor, that's 200, times the number of micro steps, 16 for our printer. That math comes out to 3,200. 3,200 is the number everyone's going to use. You're going to divide 3,200 by your previous E-steps. It's that simple. The resulting figure is going to be your rotation distance. My previous E-steps were 422.5. So the calculation I did was 3200 divided by 422.5. That gave me 7.573964, yada, yada, yada. That is now my rotation distance. We've converted E-steps to rotation distance. I want to take 3 numbers past the decimal point, so I will turn this into 7.574. I'm going to round up. I go into my printer.cfg. I erase the value that was next to rotation distance, and in its stead, I add this new number, this new value, 7.574. I want this to take effect now, so I save and restart my firmware. Final calibration before my first print, because I have a BL Touch, is to adjust the Z offset and create a bed mesh. Adjusting the Z offset, very simple in Klipper. I go to the console and I insert the command probe_calibrate. I hit enter and it executes the command. It's going to auto home our machine, and then it's going to give me a Z offset menu to begin calibrating. We lower the nozzle close to the bed, and I'm using a post-it note to feel the distance. Once I get some good drag on the post-it note, I hit apply. That updates my current Z offset. I'm not finished though. I do need to save and restart the firmware for it to take effect. So I do that. And then lastly, with the BL Touch, I'm going to create a bed mesh because I don't want to probe before each print anymore. It takes a little time. I'm actually just going to recall a previous mesh. In Marlin, we knew this as M420S1. That was the command. So now I need to create that mesh. I go to the Tune menu on the left side of Fluid. I have to auto home before I do this. And then once I do, I click Calibrate, and this runs through the bed mesh probing program. The way in which my BL Touch is going to probe is determined by my printer.cfg file under the heading bed mesh. Again, not going to go into that. It's a little complicated. There will be a future video on exactly how to tune this properly. Once that is finished, we can jump over to our slicer, make some changes, and then get our first print. We're in our slicer, and we need to make a few changes before we can slice our model for Klipper. We need to first make sure there are no acceleration controls active. I go into the search box on my profile. I type coasting. I can search coasting, enable coasting. That needs to be unchecked while we slice for Klipper. After that, I drop down my printer. I go into manage printers and then machine settings. I need to change the start G code. Klipper no longer will be reading all this G. This is going to be our first introduction to macros, and that's what we're going to use for our start and end G code. I'm going to erase everything in my start G code, and in its stead, I'm going to write start_print. That is our macro. What a macro is simply a shortcut. It's a single phrase or word that is going to execute commands. What start print's going to do is execute everything that was written under start G code for us. Let's jump back over to our printer.cfg, find an open area just like we did for that BL Touch section, and we're going to paste in the start G code macro. You can get this from my website. This macro is good for Cura. If you're using Super Slicer or Prusa Slicer, you might need to use something else. What this start print macro is going to do is anytime the printer reads start print, it's going to execute this block of code that's under it. And all this block of code says right now is exactly what it said in our start G code. We're going to get a prime line. It's going to call a previous BL Touch mesh for me, and then it's going to start printing. We're also going to do the same thing for our end G code. We're going to use an end_print macro. Then I'm going to hit save and restart firmware. Now I can go back to Cura. I can delete everything in my NG code, and in its place, we're simply going to write end_print. That's it. We don't need to make any other changes to our slicer. Close out our menus. We can add a calibration cube, something very simple to print. We can slice this and then save the file to a local folder. We go back to our printer through Fluid, go to the home screen. Now we can go down to Jobs, click the plus button, and upload this print, or we can upload and print it immediately. Whatever you want to do, I'm going to upload and print it immediately. And then our print begins, and you'll see the bed temperature is starting to rise. That means the print begins. We can also look in our console, and it'll tell us the same thing.
Folks, we're at the end. We've done it. Klipper's installed. You've seen some of the prints. We nearly cut the print time in half for this calibration dragon, and yet we still maintain this high quality. Awesome. Now, Klipper is a lot more than what we've gone over today, like I had mentioned. And exploring Klipper is what everyone needs to do going forward. I'm going to have way more videos now involving Klipper. We're going to go over the calibrations. We're going to look at how to make a bed mesh if you need it. But I highly recommend you go to the Klipper website, read through the information they have there, because it's all worthwhile. What I'm teaching you is really just stuff I've learned by reading through those Klipper docs. So if you have questions that I can't answer or I haven't answered yet, please go to that website and peruse their database. I hope this video was informative. I tried to compile as much information as concisely as I could. If you have more questions, if I wasn't as clear as I need to be, always check my website. Generally, there's a text-based article that follows these videos. Going to be the same thing for this video. Go to the comments, ask a question. I answer all the comments. Other people answer the comments, which is great. It's a whole community thing because I am an imperfect person. I make mistakes, and it helps when we have more heads, more brains looking at a problem. We solve it easier and we solve it better. Just like Klipper, the more microcontrollers we can add, the more brains we can add, the better we're all going to end up. If you don't want to leave a comment, if you want to join a broader discussion, join the Discord. We share every day. It's really awesome. I thank everyone that has continued to contribute, and I also thank you for all the feedback. I usually, at a minimum, share the thumbnail design for my YouTube videos, and I always get great feedback, so thank you, thank you, thank you all for contributing. Upcoming, we have the third section of my dual Z-axis video, Kevin aka Sam's dual belt-driven Z modification. It's awesome. The video is close to being done. I kind of skipped the line with this Klipper video because I really wanted to get this information out there to you. After that dual Z belt video, Bamboo Labs, X1 Carbon. It is almost here. I just got a shipping notification. Today is Thursday. Next Tuesday, I should be receiving my X1 Carbon. I'm so excited. Have my dad coming over to help me with that video. You're going to love it. I think a lot of people are going to get stunned by what that printer is capable of. I mean, I don't even have the printer yet, and I'm already stunned just by seeing other people's posts, reading through their Discord. I am so excited. Now, apart from those videos, I also have a filament runout sensor video coming. We're going to compare and contrast a few different sensors. So please, if you like this video, if you like what I'm doing here, want to see more, interested on keeping up to date with the Klipper things we're going to be doing to Aquila, subscribe to the channel. If you like the video, hit that thumbs up thing. It tends to help whatever algorithm is happening, helps the channel overall. So thank you all so much. I really appreciate it. And as always, until next time, boys, girls, everybody else, keep on printing.